Alright, in this video, I'm going to continue to go over practice problems for test one. So I'm going to go over the chapter three problems. So I'm not going to go over all the problems in chapter three, but just some of them. So see, look at this chapter 3.3, problem number two. So let us suppose that some article investigated the probability of corrosion of steel reinforcement in concrete structures. It is estimated that the probability of corrosion is 0.19 under specific values of half cell potential and concrete resistivity. So now the risk of corrosion in five independent grids of building with these values of half cell potential and concrete resistivity. So let the uh, the random variable x denote the number of grid with the corrosion in this building. So now x, look at this random variable x. That's denote the number of grid, right? And then with corrosion in this building. So and then each the risk of corrosion in five. I mean each grid is independent each other, right? So now we can apply the binomial distribution um, the binomial distribution. So because the each triers are independent, and then we have on we expect to outcome for each grid, right? So corrosion or not, right? So now then mean gonna be n times p, and then variance gonna be n times p times q, right? So here n gonna be 5, and the p is the 0.19, q is 1 minus 0.19, right? So you can find mean and variance. Then next problems. So a table is given. I mean, this is a probability distribution is given, right, as table. So the first column, the denote represent list the possible values of random variable, and then second column lists the probability for each values of random variable, right? And then the problems give you to find the E of x expected value and then the variance, right? Then we're gonna use the what the formula of the definition of the expected value and variance. Okay, I'll show you in this quiz paper. All right, so these problems, the d of x using the definition of expected value. So e of x is going to be sigma, right? So I goes 1 through the n, and then the xi times f of xi. So x of I denote the value of random variable, right? Ith value of random variable. And then this is the PMM, probability mass function at xi if random variable is discrete random variable, okay? And then for continuous random variable, then f of xi denote the probability density function at xi. So now the since n equals here, n is a 5, right? N is 5, and then we know the xi is going to be values in the first column, and the f of xi going to be values in second column, right? So this is equal to 1.5 times 0.15 plus 3.0 times 0.15. Okay, so and so on. I'm not going to write it this. I believe you understand how to apply the formula into the problems. Okay, so now once we figure out the all the values and adding them up, just apply the algebra. Then you're going to get the 4.175 things. Okay, for the variance, if v of x is going to be sigma I goes 1 through the n, and then f of xi times xi minus mu square. Okay, so what is mu? This is mu, right? Okay, so or we can say e of x squared minus mu square. You can use this. Either one just fine. Okay, but either one is fine. So, but let me use the second formula. And this is going to be sigma I goes 1 through the n, right? And then xi square, right, times f of xi, right? The minus mu square. So the then this is going to be 1.5 square times 0.15 plus 3.0 square times 0.15 and so on, the minus 4.1775 square. Okay, then I'm sure that you're going to get the 2.257 days square, right? Because of variance, right? Now I'm gonna let you know how to figure out these values using calculator. Okay, so in the calculator right here, so the first one we're gonna enter the probability distribution into the list. Okay, you see the list right here. Okay, but you just go you can go the list by just entering by pressing the stack. Okay, press stack. And you see the edit, right? So we just, by the way, in here in the stack there are three tabs: edit, calculate, and test, right? So we go to the edit. Then we gonna enter the you see the L17. I'm sure yeah, I think most of the you guys in your calculator there's only 6 columns, L1 through L6, maybe L5. You can create more columns. Okay, so for example, go to the L17 and then move to the next column, and then next column. You see that you can create. Okay, but I think uh, L19 is the maximum number of columns you can create. Okay, but anyway, so here I'll just enter see the L17 right there, 15, 3, 4.5, 5, 7. This is the values of random variable in the first column, right? In a probability distribution problem, right? In the L18, I just enter the probability, which is a second column in a probability distribution, right? And now L19, I enter the square of a random variable. You see that 1.5 square, which is 2.25, and then 3 square, which is 9, 4.5 square, which is 20.25. You see that here. Now, what you're going to do, once you enter these three columns, okay, and then we go back to stack, press stack, and then we go to the calculate, and then we use a one variable stack. Okay, enter one variable stack. So list, I'll enter L7. First of all, let's find the E of X, expected value. Okay, so to find the E of X, expected value, we enter the L19, which is the list of values of random variable. Okay, so L is here, is it here, right? L. Okay, the alpha C key is already on. You see that A right there is a blink, right? It means that that key is set on. Okay, turned on. Okay, so now press L. You see L right here, L, and then 17. Then we need to turn off the alpha 17. And the frequency here means the probability. Okay, so L18. Then we calculate. Okay, now you see the X bar 4.175. This is exactly the same as the answer, here. You see that E of X, right? Then here's key in mind is do not look at this sigma X. That is not the standard. The give me a second. Do not confuse with this one, sigma X. Okay, so that's the standard deviation, not variance. Okay, so you see that X sigma, and then up there you see SX. That's actually the um, the standard deviation of the sample space. Okay, but we're gonna the calculator the assume that the data is a population. Data is entered in this calculator. That data, they assume that the data is population. Okay, data set is population. So now that's why we got this. The calculator just returned the number for as a sigma x. Okay. Anyway, this is standard deviation taking square. You're gonna get 2.257. Okay. So now so actually you got the E of x and the V of x, right? And the other one, if you want to figure out by the way, if you want to figure out this one, sometimes you may need to figure out the E of X square. How can I do that? Okay, then we go to the stack again. You see that L9, that's why I just entered the square of random variable in L19. Using that L19 and then the intrinsic function one var stack in calculation tab, we can figure out E of X square. But here you don't have to do. We already figured out 4.175 and then 2.257 using calculator, right? Okay, done. But I'm just want to let you know how to figure out E of X square. So now we press set stack and then go to the calculator tab and then we press one var stack. The list is gonna be L19, right? L19. Okay. So now we got this. You see that 19.6875, right? And then that's the E of X square. And then subtracting mu squared, you're gonna get the 2.257. Okay. Let's see next problems. Chapter 3.3, problem number 7. Consider the following circuit. The probability that each device functions correctly is P1 is 0.88 and P2 is 0.72. So assume that device fail independently. Okay. So now you see, what's the random number of X? I mean, by the way, you see that independently. So this is problem of independent, right? So let the random number of X denote the number of failed devices. Calculate the mean for X. Okay, so then we need to figure out the possible values of random variable and their corresponding probability, right? So let's figure out in sketch papers. And by the way, this similar problems in the text example in textbook. Okay, you you better just studying those example before solving their problems. Okay. All right. So in this problem, what's the possible value of random variable here X? Okay, let me make a probability distribution table. Okay, because it's definitely the random variable X is a discrete random variable, so it is possible in this problem to make a probability distribution table. Okay, so this is the probability that X is equal to X. Okay, so that's the nothing but what? This is nothing but f of X, right? Which is here. This is PMF. Okay. Anyway, so X can be 0 and 1 and 2, right? That's it. Because we have only two devices, right? So now the probability X equals 0 is going to be what? It means that both devices function correctly, right? So this is going to be P1 times P2, right? Okay. And then probability X equals, I mean, P1 is what? P1 is a 0.88 times P2 is 0.72. Okay. So that's going to be 0.6336. Okay. So now probability X equals 1. It means that what? One device is working correctly and the other one fail. Then we have two possibility. P1 device P1 works correctly, but P2 fail. Where P1 fail, works P2 works correctly, right? So we think about two cases, right? So it's going to be P1 times 1 minus P2. That means what? P2 second device worked correctly, but first device worked correctly, but second device fail. Okay, plus 1 minus P1 times P2. Okay, the probability that X equals 2 is going to be P1 minus, right, P1 times 1 minus P2. Okay, all right. So this is going to be 0.3328, and it's going to be 0.0336. Now, so we copy these numbers into the table. Okay. But by the way, you need to make sure that some of these values, I mean probability, some all probability must be equal to 1. Okay, please check that. Okay, I'll skip it. but you should you have to make sure that sum of all probability in the probability distribution must return 1. Okay, so point 6336 and the point 3328. Okay, and the point 0 336. Now then E of x is going to be what? E of x is going to be 0 times f of 0, right? Plus 1 times f of 1 plus, is it 1? 2 times f of 2. Okay, so that is equal to 0.4 actually. Okay. Let's see next problem. 3.4, problem number 5. Suppose that 9 digit social security numbers are assigned at random. So the numbers may start with 0. Then what's the possible numbers for each digit? Because for each digit can be, each digit, the number can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? So there are 10 possible numbers for each digit, right? So then what's the all we need to figure out? Let me finish reading problems. If you randomly select a number, what is the probability that it belongs to one of the 300 million people in the United States? So to figure out the probability in this problem, in a classical probability, we need to figure out the all possible um, values in the sample space, and then all possible values in the event, right? So or we can say all possible observations, and then in the sample space and event, right? So let me figure out this answer in this case paper. So in the problems, so let's say S denote the sample space. Okay, so now sample space is going to be the what all possible cases for 9 digit social security number. It's going to be starting from 0, all 0 is social security number through the all 9, right? The how many possible cases? So let me say n of s. That's the number of the observations in a sample space. That's going to be 10 to the 9th power, right? Because for each social security number, okay, for each digit, the possible values, total number of possible values is going to be 10, right? 10, 10, 10, 10, 10. Okay, and then we multiply them, we're going to get 10 to the 9th power. That's going to be all possible values, possible way to create the 9-digit social security number. Now, here event going to be what? The event is all the social security number in the United States. Okay, so then n of e going to be is n. Okay, sorry, was n of e going to be what? 300 million, which is 300 times 10 to the 6th power, right? Okay, and then probability of e going to be excuse me, n of e over n of s, right? So now, excuse me, this is going to be 300 times 10 to the 6th power over 10 to the 9th power, right? Which is what? 0.3, right? Okay, it's quite simple. The problem quite simple, and then but you need to fully understand the concept of classical probability. Okay, so probability can be calculated by number of the outcomes in an event divided by number of outcomes sample. Or can say, but you can say number of the observations in the event divided by number of observations in the sample space. Okay. So let me stop here in this video, and then I'm going to continue to go over other problems in next video.